हाँ हाँ, बोला पाठक जी, गुड मॉर्निंग। पाठक सर अनम्यूट करिए, स्पीकर ऑन करिए। गुड मॉर्निंग प्रोफेसर कछुआ, वेरी गुड मॉर्निंग।
Yeah, am I audible, sir?
Yes, sir.
Yeah. Thank you very much, sir. Thank you. थोड़ा सा shall I upload my slide?
हाँ, अपलोड करनी है। आप अपने स्क्रीन से करेंगे सर? एक बार टेस्ट करना तो कर लीजिए आप।
वही मैं देख रहा हूँ, मतलब
शेयर स्क्रीन करके आप
एक्चुअली गूगल वाले में थोड़ा सा
हाँ।
गुड मॉर्निंग सर, गुड मॉर्निंग सर।
वेरी गुड मॉर्निंग सर, वेरी गुड मॉर्निंग।
हाउ आर यू सर?
एब्सोल्युटली फाइन सर, आप सुनाइए।
ठीक है सर, हम भी सब ठीक।
हाँ।
मॉर्निंग कछुआ सर, मैं सर आपका पुराना स्टूडेंट भूपेंद्र।
अरे भूपेंद्र जी, क्या हाल है? हाउ आर यू?
फाइन सर, फाइन। आप कैसे हैं सर?
हाउ योर जर्नल गोइंग ऑन? वेल,
फाइन सर, फाइन। यस सर, 8th 9th ईयर वी एंटर्ड। यस सर,
दैट्स वंडरफुल।
भूपेंद्र जी का जनरल और कॉन्फ्रेंस दोनों अच्छे चल रहे हैं, काफी रेगुलर।
बिल्कुल, दिल्ली में बढ़िया जम गया उनका।
आप यानी रेगुलर उसको आपको वो है सर उसकी इंफॉर्मेशन।
एक मिनट सर, मैं उसको थोड़ा देख लेता हूँ। सेलेक्ट विंडो ऑन स्क्रीन,
शेयर में इंटायर स्क्रीन कर लीजिए। ये एरो पे आप जाएंगे, शेयर।
हाँ, शेयर में जाने के बाद ये दिखा रहा है सर कि सेलेक्ट विंडो ऑन स्क्रीन।
योर इंटायर स्क्रीन कर लीजिएगा।
एंटायर स्क्रीन, अच्छा एंटायर स्क्रीन हो गया सर।
डेस्कटॉप अपना खोल लीजिए।
हाँ, हेलो। एक सेकंड सर, मेरा स्लाइड्स विजिबल है सर?
यस सर।
अच्छा, ओके फाइन सर। मैं इसको ऑलमोस्ट इसको कर देता हूँ। पॉल साहब, कॉलेज आपका कब खुल रहा है? स्टूडेंट्स वगैरह
कॉलेज तो सर अभी एक सेमेस्टर तो और प्रिकॉशन रखनी पड़ेगी। चांसेस वैसे कम है थर्ड वेव आने के, बट अनसर्टेनिटी तो अपनी जगह है,
बिल्कुल
नहीं सकते, क्योंकि पब्लिक मेंटेलिटी एटीट्यूड है ना, वो प्रिकॉशनरी नहीं है।
करेक्ट।
मोर देन 50, 60, 70% पीपल आर नॉट वेयरिंग मास्क, नॉट टेकिंग सैनिटाइजर।
ये इश्यू है अभी तो
एक असेसमेंट यही है कि मुझे लग रहा है कि शायद 50-60% लोगों को हो चुका है। तो वो पॉसिबिलिटी है कि विद इन 6 मंथ तो अभी कुछ नहीं होगा, उन लोगों की इम्यूनिटी बनी रहेगी। आज भी एक स्टडी आई है, उसमें आया कि 1 या 1.2% ओनली री इन्फेक्शन हुआ है।
अच्छा, यही हुआ है।
तो अगर सभी लोगों में इन्फेक्शन आ गया तो फिर जो अगर 20% लोग बचे होंगे तो उनसे वो इन्फेक्शन स्प्रेड भी बहुत कम होगा।
ये भी है।
अगर किसी को हो भी जाएगा तो अंडर कंट्रोल रहेगा।
दैट्स अ गुड थिंग।
बट आफ्टर 6 मंथ क्या होगा वो नहीं कह सकते सर। हमारी वैक्सीन कितनी इफेक्टिव है या इम्यूनिटी है तो 6 महीने की बात है। अगर वो वायरस थोड़े छोटे छोटे लेवल में भी 6 महीने से ऊपर सर्वाइव कर गया और उसके बाद फिर वो अटैक करेगा, या बाय दैट टाइम फिर पॉलिसी मेकर फिर करें कि हो सकता है सेकंड डोज के बाद हमें थर्ड डोज के प्रोग्राम में जाना पड़े।
ऑल वेट एंड वॉच वाला गेम है।
हाँ, क्योंकि वर्ल्ड वाइड भी 6 महीने में एक्चुअली इंटायर वर्ल्ड को वो कवर करना वो भी एक बहुत बड़ा चैलेंज है। वो अभी प्लान भी नहीं है।
अपने अभी तो अभी क्या था 35 करोड़ हुए हैं अभी ऑलमोस्ट, मतलब
हाँ,
करीब
जैसे इंडिया में तो हो जाएगा, पर फिर भी इंटरनेशनली से आया, या हमारे जो फर्स्ट डोज वाले हैं उनका भी अगर 6 महीने से ज्यादा कवरेज रहेगा कि नहीं,
ये भी है।
तो हो सकता है उन लोगों को जो फर्स्ट डोज में मार्च अप्रैल से 21 से पहले जिन लोगों को हुआ है वैक्सीनेशन, उनको एक डोज और देना पड़े।
बिल्कुल। आपका ये प्रोग्राम तो बढ़िया हो गया सारे स्पीकर्स का?
प्रोग्राम तो अच्छा चल रहा है, सारे शेड्यूल ऑनलाइन में। ये थोड़ा एक कन्वीनियंस रहता है कि कैंसिलेशन या उस तरह के प्रॉब्लम नहीं आते हैं।
नहीं आती है।
तो फिर भी कल कुछ नेटवर्क में थोड़ा सा प्रॉब्लम आ रहा था। इंटरनेशनल जो एक्सपर्ट थे उनसे, बेल्जियम से कर रहे थे डॉक्टर मनोज कुमार सिंह।
अच्छा।
सर गुड मॉर्निंग।
और आफ्टरनून में
गुड मॉर्निंग।
या गुड मॉर्निंग रामचंद्र सर। गुड मॉर्निंग विनीत। So sir, 30 participants have joined. I think just as this number reaches to 40, I will ask Dr. Junaid to introduce you.
अभी आप लोगों को रिसर्च स्कॉलर का परमिशन है एंटर होने का, रिसर्च वगैरह जो करते हैं स्टूडेंट्स?
So very good morning everyone. Very soon, within 1-2 minutes, we will be going to start. Yeah, Dr. Junaid.
Yes, sir. Yes, sir. Sir.
Yeah, I think we may start now. 43.
हाँ सर, एक मिनट मुझे और चाहिए सर, within 1 minute.
Yeah, no problem. Very good morning to all the participants. Please mute your microphones. Participants, please mute your microphones.
Good morning, sir.
Very good morning.
Good morning, sir. Good morning.
Good morning,
sir.
Prasanji.
Good morning, sir.
Good morning, Neeraj.
Thank you.
Very good morning.
Good morning, sir. Good morning, Amit sir.
Good morning, sir. Das sir. Very good morning.
Okay, sir. I'm ready,
Morning,
sir. So
Yeah, sir. We are at Golden
okay,
Jubilee. 50 participants joined, so you may start now.
okay, sir. So I am inviting.
I will request Dr. Junaid.
Yes. So I am inviting Professor Surendra Kachhwaha for the presentation on the talk role of the emerging cavitation technologies in the sustainable growth of bioenergy sector. The Professor S.S. Kachhwaha completed his BE degree in the mechanical engineering from the MBM Engineering College, Jodhpur. He did his MTech in thermal power from the Indian Institute of Technology, BHU, Varanasi, and the PhD in the evaporative cooling from the IIT Delhi. Professor Kachhwaha has taught various thermal engineering courses at the undergraduate and the postgraduate level and guided 30 MTech dissertations and 3 PhDs. He served as a faculty in Rajasthan Technological University at Kota and Delhi Technological University at Delhi in the past. Presently, he is working as a professor and head Mechanical Engineering Department in the School of Technology, Pandit Deendayal Petroleum University, Gandhinagar. He has accomplished research projects and consultancy work of worth for crores. He has a teaching experience of more than 28 years in thermal engineering at undergraduate and the postgraduate level. Professor Kachhwaha has around 50 technical publications in reputed national and international journals and more than 60 publications in national and international conferences. His research interests include evaporative cooling, ice slurry generation, poly generation, offshore wind energy, and biodiesel production techniques. So I am inviting again Professor S.S. Kachhwaha for deliver the talk on this faculty development program. Please, Kachhwaha sir.
Yeah, thank you very much, my friend. And I am very thankful to the organizers of this very important STTP, role of renewable energy sources in Indian energy security. The topic is very relevant, and very good morning to all the participants, listeners, and I hope that everybody is safe at their home, and safety is the one important aspect. And I will see that this technology is also very suitable in the post-COVID era. This technology can play also a very important role. So I'm thankful to Dr. Pal, with whom when I deliver a lecture in DTU, it is just like a homecoming, because I was the 6 to 7 years I was faculty member in DTU, and really I miss DTU. And whenever the opportunity comes through online, that's really a wonderful experience for me. So once again, thanks a lot for organizers to inviting me for this online seminar. And in fact, I started the work on this bioenergy with Dr. Pal 1 decade back. And if you just visit the biodiesel laboratory of DTU, the cavitation techniques almost can say we have developed that particular plant, and that plant is the first in the league. It was there. Dr. Palsa, how much time I have to take? Just tell me the time duration. How much time I have to take?
You may take 1 hour to 1.5 hours. and after that we'll be having a half an hour discussion session.
Okay. So I'll just keep it as 1.5 hours and then half an hour as a discussion. Correct. Yeah. So now this particular topic, role of emerging cavitational technology in sustainable growth of bioenergy sector. I'll just tell you the background. In bioenergy sector, the point is that fundamentals remains the same. Whether it is a energy product, maybe biodiesel, or maybe you can say bioethanol, or whatever it may be. The fundamental means equations and the reactants, equations, they remain the same. But main issue is that how to convert that knowledge into technology. That is always remains a challenge. And if the technology is not viable, then industry will not follow it, and there will be problem, right? So technology point of view, equation point of view, knowledge point of view, fundamental point of view, the knowledge remains same, and people are aware of that one. Main issue is that apply the technology so that that conversion becomes sustainable and that can be utilized for industrial applications. So from that point of view, the cavitation technology, people call it as a breakthrough recently, and this technique is nothing but, you can say, whatever the reaction it is there, it will enhance that reaction in that particular direction. In general, without giving an example, I will say that A plus B, which is a reactants, it converts into C plus D. If your fundamentals are clear, in that case, this technique will enhance in the sense that energy requirement will be less, catalyst requirement will be less, time consumption will be less, and your catalyst or any other requirement that is also less, and your total conditions will be almost within the environmental conditions you can achieve it, whereas the conventional technology requires a lot of time, lot of energy, and big size systems are required. So from that kind of view, across the world, last 2 to 3 years, a large number of papers are coming, and it is still at a developing stage. Normally, what happens in the audience, there may be, I assume that there may be a mixture of all the young.
I think your slides are not changing. Have you changed the slide?
No, yeah, I'm changing. I'll change. I'll just giving a background and then I'll change. The point is that these techniques, from mechanical point of view, mechanical engineers teach the fluid mechanics, and then they say cavitation should how to avoid the cavitation or how to reduce the cavitation. Whereas this is only one side of the coin. If you go to other side of the coin, is that for chemical engineering or not, now earlier it was chemical engineers. Now almost all discipline people work in that area, and how you can utilize the cavitation for peaceful purpose or for application purpose. So in that point of view, we have to control the cavitation, and it is a very, very positive aspect. So almost you can say I have seen in my career, I have seen the two sides of the coins. In one side, how to avoid that cavitation in pumps and turbines, and now the other is that how you can enhance the cavitation for enhancing the reactions and other things. So from that point of view, with this aspect, I'm just talking about that points which I'm going to cover is that what are the different categories of the fuels, what are the fuel resources, and for those fuel resources, what kind of cavitation process techniques we will follow, and I will classify those techniques, and these techniques, what are the fundamentals of that one. 3 or 4 techniques are there. Ultrasound, then for further enhancement, microwave can be added with this one, then your hydrodynamic cavitation techniques, and then the rotor stator technique, which I will explain in details. Then I will come to the application part, which is almost, can say, biodiesel production. Of course, we are working that continuously 4 to 5 years we are working. Same techniques can also be applied for bioethanol also. And another important application is that in pre-treatment processes, we can apply the biogas production also. Even in hydrogen, there is nothing new. Technology point of view, people know that this is a reaction that is happening. But the same reaction, if you just, below, if you supply the ultrasound, in that case, what will happen? The 10 to 20% hydrogen will be enhanced. Across the world, people are working the hydrogen. Ultrasound can enhance the reaction. Then besides this one, another application is that ultrasound extraction from cash crops. How to enhance the farmer's income. From that point of view, this process intensification technique can play a very important role, and it can certainly incorporate it in the agriculture. Then what will happen? it will certainly enhance the income of the farmers. Of course, this is not related to bioenergy, but the point is that in that case, this recycling of spent, is there any disturbances are there? I request the participants to mute their mic.
Harjan Das sir, please mute yourself. Your mic is open.
Okay.
Dr. Harjan Das.
Okay, sir, I will do it.
Okay, sir.
Yes, sir, you may continue.
Yes, so I will continue. So another important application is that nowadays a lot of stress is given on lithium-ion batteries, and once the battery is spent, what to do with that one? In that case, what happens? We can have recycling of spent fuels, and this techniques can play a very important role for sustainable recycling. That part is also very important. So with these, can say index, I will start my discussion with the different renewable fuel categories, and basically the main fuel which is used for energy fuels: biodiesel, substitute for diesel; bioethanol, substitute for petrol; hydrogen, it is added with natural gas to increase the flame velocity, so that the performance in a gas engine increases, and almost natural gas in Delhi it is used, and the percentage of hydrogen is also mixed. But what is the sustainable source for hydrogen, and the techniques should be energy efficient as well as industrially viable. Still people are searching, and across the world people are working, because hydrogen is considered to the best fuel because it has no impact on the environment. Besides this one, biogas, since we are agriculture based country, so biogas is not a new thing, but how to increase the quantity as well as how to increase the quality of biogas, that is challenge. And besides this one, the battery is now another introduced, and how this battery can also be using those techniques, how we can improve it. If you just consider the sources, categorize almost recently, you can say the Tamjidi et al. He has classified the different sources: vegetable oils, animal fats. Of course, we are in our country, animal fats are little bit due to can say religious purpose. We are not using that one. Otherwise, any can say lard, tallow, poultry fat, fish oil, they can be converted into a biofuel. Vegetable oils, the edible oils are there. Edible oils, what happens in our country, we know that price of the vegetable oils are very high, and if you convert that one, again there will be a lot of problems. The food versus fuel crisis is there. So we cannot use the edible oil for conversion of biofuels. But those countries which are having excess edible oil, they always go for conversion of edible oil into biodiesel or biofuels. So normally you can say sunflower in China, then cotton, groundnut, cottonseed, soybean, barley in US, wheat, coconut, various resources are there. So according to the resources, in whichever of the country which is having higher, they will utilize those resources to convert into the biofuels. In our country, fortunately, we have a large resource of non-edible oils, and Kachhwaha, of course, one source, but it is not a very successful. In our country, where I am delivering a lecture from Gujarat, castor production in Gujarat is not only in India, it is the highest in Asia, and a lot of castor is exported to the foreign countries, and it has a lot of, can say, vertical products are there. So castor can play a very important role. Of course, oil has a typical properties, but we have worked on in that area and see that castor can play a very important role in this biofuels. Besides this one, other non-edible oils, you can say bitter almond, rice bran, then your sesame, then your various palm oil. Palm oil we are importing from Malaysia. The point is that non-edible oils can always play a very important role. And besides this one, the one important term which is not included is the waste cooking oil, because in our country edible oil is not there. But the point is that once you use the edible oil, then a huge amount of waste cooking oil or unused cooking oil is, can say, we have a storage of that one, and that can become a large source. Therefore, the future strategy must be that waste cooking oil plus this waste cooking oil plus this castor plus non-edible oils. So, combination point of view, it will be an important one. So, in this point of view, the point is that the combination of non-edible oils, waste cooking oil, and castor, they can play a very important role. And particularly in case of, in our country, we know that diesel consumption is 3 to 4 times higher as compared to the petrol, and therefore, whenever the price goes high, nowadays prices are continuously rising, and diesel can play diesel price rise in diesel will have a lot of impact on the economy, and economy can be in doldrums. So therefore, resources, proper utilization of resources are important. Now, in case of bioethanol, there are first generation, second generation, third generation, and the fourth generation is there. We are almost, we can say, first generation, again, the food, we cannot use, the food items, we cannot use it, right? But in second generation, non-food biomass, we can convert. Even nowadays, the policy has changed. The grains which are not edible or they are just rotten, so those grains can also be used in the case of second generation conversion of bioethanol. Number of steps are quite large in bioethanol, and I will see, in my next part, I will just show you that these steps can be clubbed and they can be minimized, and with less stringent process conditions, we can produce the bioethanol also, just like biodiesel. And then the third generation, of course, there is the algae and other parts are there, and they can be genetically, if they modify that one, then we can call it as a fourth generation. But the long journey is there, and with the long journey, it will take a time. Even in microalgae, etc., people are working, but the industrial application is still yet to come. Reliance and other industry, big industries, they have entered into that area, but they have yet to come with the final product. This is always a research level, and there is a controversy also there. It will be very difficult. But of course, initial research data shows that algae can play a very important role. And we know that even 1 hectare, if you compare the 1 hectare of algae, the biodiesel produced by 1 hectare algae is equivalent of 8 hectares of non-edible seeds and other things. So choices are there. Let us see that what happens in the future. But just in near future point of view, this non-edible oils will play a very important role. And in case of bioethanol, the sugar bagasse and other raw products are there. Using those raw products, we can convert into the bioethanol as a substitute of petrol. This is a scenario available, and these raw materials we have to utilize in a proper way, and there must not be, the food crisis must not be created. And that's very, very important, where in our country a very high population is there and main agriculture it is there. So a typical balance must be there between the food and the fuel. That's very important. Now, before I come directly to the solar reactor, I'll just classify that, or before classification, I can say that normally can say in conventional techniques or in reactions or anywhere that is there, the mechanical stirring is the most commonly used from last 3 to 4 decades people are using. And in that case, the 2 immiscible layer of liquids are there, and they are continuously stirred by using a mechanical stirring. I have not shown the diagram, but due to, I can say, this diffusion, which is a very slow phenomena, time consuming, sometimes high pressure requirement is there, it requires reflux conditions. So this conventional technique has become outdated but there is no choice. Your industry, it is following, right? Until unless some alternative is given to you, the industry. So time consuming, energy intensive, and requires a lot of, you can say, stringent conditions. Due to that one, the conventional mechanical stirring is now almost outdated. Now, what is the substitute for that one? The techniques which can substitute those this conventional mechanical processes are nothing but, you can say, we can call it as cavitation technologies. And this cavitation technology broadly can be classified in terms of, based upon sound waves, we call it as a sonification, and due to pressure change and velocity changes, we call it as hydrodynamic. But more or less the principle remains the same, and in both the cases, both are complementary to each other. Sonication and other techniques, what happens? Scientists have worked a lot, particularly science stream, because it suits them. Whereas engineering point of view, people have worked in hydrodynamic cavitations because they are much more familiar with pump and applications of pump, orifices and other things. But remember that both are complementary to each other. If they come, normally can say scientists, they have worked only into that area, and they think that, okay, successfully they have come out with the product, publications, patents, and promotions and other things, and they celebrate it. But this journey is only 50%. Why? Because industrial applications, little bit problems are there. engineering point of view, if they directly start with hydrodynamic, then the sample size and other things, it's very, very difficult because they have to perform a lot of experiments. These two techniques must be clubbed to each other. If sonication, the results are good, then that can be easily extended up to hydrodynamic. So both the combination can make the journey complete and the outcome is wonderful. So both these techniques, normally they comes under the cavitation technologies. So here I will just talk first about the ultrasound and then I will talk about the hydrodynamic cavitations. And both these techniques, people call it as a breakthrough nowadays. And across the developed world, it is working. And last, I can tell that 2 to 3 years, tremendous momentum is there in the techniques. Almost all walks of the life, whether it is a fuel area, this energy area, or in non-energy areas, water, wastewater, recycling, anywhere A plus B becomes C plus D. Means if our fundamentals are clear that this is the reaction, this is the products, in that case, these techniques will enhance in that particular direction and in a very fast. Whatever you are getting in hours, you can get in minutes. And that is the beauty of those techniques. I'll just explain that in ultrasound, what happens, we have a generator in which the important portion is the amplitude and frequency. And here it is our sample size, right? And in that sample size, what happens, this is your typical horn is there. And through this horn, the sound waves are continuously emitted in the bottom portion. Now, since it is horn type, it is called as, this horn type of ultrasound reactors. If it is a bath type, from the bottom portion, if you just have ultrasound, we can call it as a bath type of reactors. And normally what happens, it is a high power, low frequency horn type reactor. And normally we call it as high intensity focused ultrasound is considered to be the most advanced one because due to this high intensity, what happens, the reaction becomes very fast. Now, what is the mechanism? Normally what happens, through this ultrasound, this horn, the sound waves are emitted. And when sound waves emits, what happens, just look at this another diagram. When the sound wave travels into the liquid, there is a continuous compression and rarefication. Rarefication means expansion. So this is cyclic. C is for compression, R is for rarefication means expansion. So CR combination, it continuously goes. And in that case, whatever due to this cyclic phenomena, the bubbles are generated inside this sample. And those bubbles, the size will also continuously cyclic depending upon pressure or expansion conditions. And finally, when a typical condition comes, almost we can say that this 5000 Kelvin or 1000 atmospheric conditions, a very micron level. Remember that it's a micron level. System macroscopic level, it is atmospheric conditions. But micron level, temperature becomes very high and because these are nanobubbles and pressure is also very, very high. And due to this one, what happens, your reaction becomes very, very fast, right? So this is the main reason for success of this particular ultrasound. The high power ultrasound is introduced into the liquid medium, causing the sound waves to transmit in the fluid and create alternating high pressure compression and low pressure rarefication cycles, which the frequency dependent rate of oscillation. This is a real success of almost, you can say, and normally chemistry people call it as sonochemistry and sonohydrometer physics people call. So depending upon, we should not call it as that it's a chemistry, something like that. But nowadays almost mechanical engineers have entered, even environmental engineers have entered. So point is that if a system which can solve a problem, then engineers have interest. And almost scientists, their reactions, another point of view to enhance the reaction, etc. Lot of papers are available as far as the science development is concerned. So therefore, ultrasound has played a very important role in development of concepts or enhancement of the concepts. From that one, ultrasound contribution is tremendous. So due to this one, what happens now, I will talk about the mechanism, that due to which mechanism this concept I have given, that continuously compression, rarefication is there. But point is that actually what happened, why the reaction is enhanced, why the product yield is very high. For that one, I'll just go to the next slide, where the different features of ultrasound is there, and these combined features worked very well, which is not present in case of mechanical string. In that case, the very slow reactions are there, and it takes place in hours, sometimes hours, maybe 10 hours or 15 hours. Whereas in this case, even whatever the stringent reaction it may be, but within half an hour or within total 1 hour, complete reactants can be converted into products. The main feature is that time and energy saving, right? The reason is that there is a macromolecular mixing caused by acoustic irradiation and the generation of hotspots, right? So microscopically fast changes, and when the I'm using a word implosion, it is not explosion. When I can say bubble becomes size increases and explodes, then we can call it explosion. But here the bubble implodes means it becomes smaller once it is can say once it is broken. Then the point is that implosion of the bubbles takes place, and due to that one, the mixing rate becomes very, very high. Now, another reason due to this mechanism, high yield we can get, and selectivity. Selectivity may be varieties, different varieties of selectivity is there. So what happens? Physical and chemical transformations are altered because of the cavitation phenomena, causing efficient agitation, dissolution, very high heat and mass transfer rates, and reagent sonolysis. Now, due to this one, what happens? The different selectivity. What are those selectivities? Chemoselectivity, regioselectivity, and stereoselectivity. All these selectivity enhances, and therefore the overall selectivity will increase. And once the overall selectivity increases, automatically the obvious choice is that high yield quantity can be achieved. Another important thing is that normally you can see in any reaction, the catalyst play a very important role to enhance that reaction in a particular direction. Now, in that case, what happens? The requirement of catalyst is also less. Why? Because in high reaction rates, what happens? We know that these are the very important terms, the formation of hydrogen ions, OH, HO2, O. These ions, cations are also called as radicals. The formation of these radicals, and this has been, you see, these are only at nano level. And a conventional instrumentation, we cannot find out that C to it. But very sophisticated instrumentation, people have observed that these ions play a very important role, and they are the part of the reaction itself. So radicals causes the reaction rate to increase, and this leads to faster redox reactions. And once the faster reaction is there, turbulence is created, and due to the propagation of alternating pressure waves, means compression as well as expansion, enhances the mass transfer rate. So these things, what happens? These radicals act as a they act as a catalyst. So therefore, once they act as a catalyst, no need of actual catalyst requirement. So partly you can say you can reduce the quantity of reactants of this catalyst. And remember that catalyst in many cases it is a pollutant. So any small amount of reduction of catalyst can play a very important role to improve I can say improve the quality of the process. And as I have told you that we can get very high extraction yield because this is achieved because of site-specific cleavages or season. An example is that green tea, as an example where ultrasound can be favorable to extract valuable cations effectively. So there are many, you see, this will have an ultrasound waves will impact on the surface, and it will break the outer surface, and then whatever side it is there, it can easily, due to diffusion, it can extract. Another important aspect is that better morphological properties. Actually, what happens when micron level bubbles are there, they act as a microjets. And once the bubble implodes, then it is just like a very small micro level shock waves are there. And those shock waves substantially influences the chemical composition and physical morphology of the solids. So due to that reason, even this has applications for manufacturing also, where the surface finish is better through this cavitation techniques. The people are working, production people are working, and this is a new area where using the cavitation you can improve the surface finish. Amorphicity, it is related to the cooling rates. Many of the cases, what happens that due to reaction or due to change in temperature, crystallization takes place. But here, the reaction rate, cooling rate is very, very high, and due to that one, the crystalline possibility is neglected and negligible, and due to that reason, this ultrasound is preferred to avoid the crystalline counterparts. Certain drawbacks are there. If the cavitation is not controlled, in that case, what will happen? The bubble collapses rigorously, which can cause undesirable effects also. So therefore, controlling of the this bubble formation is also important. Here you can see that suppose this is a typical chain of microalgae and bionutrients are there inside, they are stuck inside this algae chain. So whenever these bubbles come to this portion and bubble, for example, say a bubble here, it is in contact with the microalgae chain, and if blasts, or we can say it implodes, then this yellow color bionutrient is there through the structure broken of the structure, it will automatically come. And this happens only at atmospheric, can say macroscopic level, that temperature and pressure is just like atmospheric, but at microscopic level, very high stringent temperature and pressure condition is there, right? So almost in biotechnology, this mechanism can be used. Ultrasound, very good. Mass transfer rate, very high. But people still want more further improvement because it has a limitation of heat transfer, because heat generation is less, and therefore in a localized way, the product cannot be removed due to the heat generation. Then what people do, they have developed a hybrid reactor, and almost this is a reactor which we have purchased from China. The reason is that, you see, there is nothing like rocket science. From this portion, it is just like, you say, if you remove the bottom portion, then it is like a microwave. So from this portion, the microwave is there, and from bottom portion, the ultrasound is there. So in this sample, what happens? We are using the 3 fields. One is the ultrasound sound wave field, and from left-hand side, there are 2 fields, electrical field as well as electromagnetic fields. So when the 3 fields simultaneously act on a sample, the reaction becomes very, very enhanced, and the product yield is very good as compared to individual microwave, as compared to individual ultrasound. Now remember that it looks very simple, then why it is imported? The reason is that, you see, if you put this horn inside that one, then any metallic portion cannot come in front of this microwave, right? So from bottom portion we have to supply it. So in a proper way, due to its position itself, Indian manufacturers are not manufacturing. Otherwise, if any Indian manufacturer produce this one, we know that microwave, it is hardly 1 lakh to 2 lakh, a big size. A smaller size at household purpose, we can have in terms of thousands we can purchase. Ultrasound for 50 watt to 150 watt, or 1 kilowatt, 2 kilowatt, maximum 1 to 2 lakh you can purchase. But you see, when you purchase this imported one, it is 10 to 12 lakhs. So that's why as a faculty, or as a combination of mechanical, chemical, and you can say electronics engineer or instrumentation engineer, if you produce this particular, can say, simple device, even for simple, small sample purpose, even then it will sell like a hot cake, and it is not a rocket science. One can try for that one, and in the market will give a very, very positive response for this one. But at present, the scenario is that we are importing, and almost, can say, in our laboratory we have paid 12 lakhs to 14 lakhs to purchase this one. Whereas if you indigenously developed, hardly within less than 5 lakhs, I can guarantee that one can produce that one. So this is a very important problem, and combination of engineers, they can produce this one. Now remember that I have talked about ultrasound, right? Ultrasound, laboratory purpose, very, very successful. But the moment when you go to industry purpose, what will happen? There is limitations are there. But nowadays, in my couple of next slides, I'll just show you that even ultrasound can be scaled up, but up to a certain extent only. So industrial point of view, the main thing is that how we can scale up the quantities. And from that point of view, this hydrodynamic cavitation, which is very simple, but it is considered to be a breakthrough. And it has inserted, I have seen that. And in fact, with Dr. Paul, we have produced one paper, and almost our experimental apparatus is there in biology laboratory on the 2nd floor of this DTU. This is a very simple techniques, and we have seen that 50 liters within 10 minutes, 20 minutes, we can produce the biodiesel. This technique, not only for biodiesel, even if your wastewater is there, even if your any other can say application is there, energy application, non-energy applications, liquid applications, liquid plus solid applications are there. Solid means very fine particles are there. Even then, this technique is very, very suitable. In that case, what happens? We purely use mechanical devices, and these mechanical devices are orifice. It may be, you can say, venturi type, a circular venturi, or a rectangular venturi. All 3 are good. Rectangle venturi gives a little bit better result, but simplicity point of view, manufacturing point of view, orifice is considered to be a very successful one. So these are very simple devices, and even in the presence of, in the absence of qualified staff, it is also suitable, and therefore developing countries, you can say, no need of very high expertise is required, not required, and semi-skilled person can operate these devices. This is a very important aspect of this technology. And principle is very simple. We know that suppose some fluid passes through a restricted zone, maybe orifice, maybe a venturi, or maybe any, I can say, very restricted zone it passes. What will happen? We know that upstream side pressure is high. When the liquid passes through the zone, what happens? The pressure will reduce, and due to increase in velocity. And in downstream side, what happen? The pressure recovery will be there. Velocity will reduce, and again the pressure recovery is achieved. Now, in this whole process in the downstream side, what happens? This, due to Bernoulli's effect, what happens? The fluid in the chemical reaction is achieved. Vapor pressure, as it accelerates through these constrictions, means this small passes, creating a local boiling effect, which adds in agitating the mixture as a whole, often known as hydrodynamic cavitation. Means the vapor pressure is reduced so low that even vaporization will take place. And due to that, what happens? There is a formation, growth, and implosion of cavity bubbles. So here, due to this movement, what happens? It will take place. This formation is a very important one, and this bubble formation means it is in a dynamic movement, the transition and bubble formation will take place, and they play a very important role. Hydrodynamic cavitation commonly occurs in fast moving fluid because fluid is moving, and this pressure difference is hardly, you can say, 2 to 3 bar, which can be achieved through a pump itself, right? So this is not a very high pressure device or a very low pressure device, or almost, you can say, from atmospheric conditions, upside pressure is upstream side pressure is 2 to 3 bar higher as compared to the downstream side pressure. And in this zone, what happens at micron level? Bubbles are formed, bubbles growth takes place, and collapse of the bubble will take place. And but what is the mechanism, how to incorporate for modeling purpose? Still, it is currently poorly understood. So you have to, based upon your results, you have to develop the instrumentation and other things, aware our device also. So non-linear interaction takes place between bubbles and turbulence, and this concept, almost it is called as a controlled cavitation, which has a wide range of industrial applications and considered breakthrough technology. How this concept we can use? For that one, we are having this hydrodynamic cavitation reactors. Now, earlier in the case of there was 50 ml can say plant was sample size was there. Here we can use from 50 liter to 100 liter, 200 liters, 1000 liters, something like that. From this capacity, we can use this double diaphragm pump, and if the size is very large, we can have multi-channels will be there. So through that pump, we can supply the mixture, which passes through an orifice plate, which is shown here. The number of plates, number of holes, etc., you can increase depending upon the flow rates and other things. And when it passes through this one, what happens? The micron level in the downstream side, the bubbles are generated, and they enhances the mass transfer as well as the heat transfer rate. And again, the circulation will take place. And we have observed that whatever 50 liter or 100 liter in mechanical sting, it requires 5 to 6 hours. In that case, what happens? It can be converted in terms of 20 minutes to 30 minutes, you can get the result. So from that point of view, this technique is a very, very important one. But remember that since the sample size is very large, you cannot go multiple experimental data. So for how to get the experimental data, what should be the process parameters and other things? In that case, for smaller sample size, ultrasound is a very good. So first, get the results on ultrasound, get confident, and then switch over to this technology with some fine-tuning adjustment. You can get excellent results through when it passes through the orifice. So this technique, almost you can say, last I have seen that in the literature, it is gaining a tremendous momentum in petroleum sector, in case of this biotechnology sector, fuel sectors, then your paper production, and your waste lubrication, and this recovery of waste water, waste sludge. You just name it and I will tell you. Any reaction-based technique, the point is that this technology will enhance the same process, and due to that reason, everywhere it is increasing. Even in metallurgy, now people are following that. It's called as hydrometallurgy, where this technique is applicable. So From that point of view, this technique I have just briefly explained, and this technique very easily in laboratory with you can say no sophisticated instrumentation is required, and easily manufacture we can in a small scale industry one can manufacture those things. Now I have talked in this hydrodynamic cavitation based technology scale of point of view, they are much superior as compared to ultrasound. But initially you can say ultrasound is good to get the data and adjust the process parameters. Now another technology which is called as rotor-stirred technology, and sometimes people call it as a shock wave power reactors, hydrosonic reactors, various names are there, but rotor-stirred technology is well established in the literature. Now this technique, what happens, it is a very simple one, but it was developed in industry, and industry has earned a lot of money in Europe and other things, and it has kept classified technology because nobody understands, and it has been kept very confidential for last 7 to 8 years. But finally it has come in the open market, and now I have seen that even still there are number of papers available is very less. Hardly there are, can say in biodiesel 3-4 papers, in other than other fuels there may be almost 3-4 papers. So hardly 10 to 15 papers are available. The reason is that this is a very, very efficient technology and very simple also. I will explain that one. In this diagram what happens, there are two concentric cylinders are there, and this outside cylinder it is called as stator cylinder, right? Stator. Inside the cylinder, which is a rotor, we can call it a rotor, right? Inside rotor, if you just look at the diagram, it is like this almost. Again, for manufacturing engineering point of view, if you want to produce this rotor through manufacturing, then you can go for 3D printing also. It is a very good problem for 3D printing. So you can see that these are the blind holes it is produced, right? If there is no hole and this particular rotor rotates, then we can say it is a fluid mechanics problem, that two concentric fluid flowing between the two concentric cylinders. But since on the surface there are blind holes are there, maybe you can say size maybe diameter maybe 60 mm and length maybe 46 mm. This is the diameter of this particular cylinder. The whole diameter maybe you can say 4 to 6 mm, and the depth maybe 3 to 4 mm. It is like this. Now what happens when the rotation of the cylinder takes place, say for example around say 3000 rpm or 4000 rpm, whatever the liquid inside it is there, what will happen? This cavitation conditions means the pressure becomes very low, and due to that one the vaporization will take place, and the liquid will can say cyclic way, the liquid will enter through this one, vaporization will take place, and will come out in terms of shock waves. So due to these shock waves, what happens, this implosion of the bubbles, the mixing of the two liquids will take place. Even there are many types of emulsions are there, even then in that case this is suitable one. So this technique is the best as far as the mixing is concerned, and any can say whatever you can try with this one. Manufacturing is also simple, and nothing, no rocket science is required.
40, 20.
Please,
Okay,
please.
Mayank Pandey, please mute yourself.
Yeah.
Dr. Mayank Pandey, please mute yourself. Okay, sir.
Yeah. Thank you.
Okay,
so now the point is that this technique, you can see that this is a very simple to manufacture, but it is always, you can say, in industry point of view, this application has not come. So almost it can become a very good project for industry point of view. When this manufacturing student can do that one, chemical student can participate, mechanical student can participate in reactions. So in a typical combination way, this design is very, very simple design, but it gives a wonderful results. So as compared to hydrodynamic cavitation, what happens in that case, pump is there and no static device. Here, this is a moving rotor is there, but the results are very good, and there is a continuous shock wave at a micro level it is generated, and therefore, even in milk industry where if you want to convert milk into powder, then also some good quality milk is required, and this homogeneous viscosity must be there, so this will produce this one. And if you want to convert powder into again milk, even then this technology is very good. The point is that in whatever the direction your reaction is there, so this will enhance into the direction in a very perfect way. So this technology, the main, you see, these are the reactants, reactant A, reactant B. You can mix it here, and you can run it for 5 to 10 minutes, and with some with the outlet, can say this outlet through outlet, you can get the product itself. It may be, you can say, batch type of production. It may be your continuous type, depending upon your design and other conditions. So this rotor, who rotates? An electrical motor is there, and 3000 rotation machines are available. It can rotate that one, right? So this technique almost, you can say, very successful in biofuels as well as non-biofuel applications. Even in biotechnology also people are using. So main thing is that temperature and pressure conditions are atmospheric conditions. And at these conditions, the cavitation conditions are generated and the microjets are formed, and they have, they just act as a shock waves, and due to that one, the mixing takes place very high, right? So main feature is that very high speed and high shear takes place. And this relative motion between the stator and reactor, they develop mixing energy, shear, turbulence, and cavitation. These are the mechanism. And when the cavitation causes vapor bubbles to initiate growth and collapse in the liquid state. And finally, the pressure recovery takes place due to strong shear stresses. And due to that, due to this mechanism, what happens? Localized point, high temperature, pressure, and velocities are generated at microscopic level, and which enhances the process and enhances in a significant way, right? And due to this important salient features, what happens? This technique is very, very suitable for industry applications, where for wide range of cavitation regimes and inexpensive equipments can be manufactured and easily scalable. If you just look at the applications, then emulsification, always most welcome. Homogenizing, again it is used. Dissolution, dispersion, or grinding process, it can be invariably, without any second thought, we can use it. Chemical reaction, to enhance the chemical reaction, and the cell dispersion, particularly in microalgae, this can be used. And the reason is that high shear stress, high mixing energy, and elongation stress and turbulence. These are the main mechanism due to which this is very successful. And if you look at even you see apparatus size is not big. This is a typical hydrostatic reactor where outside cover is a stator, inside it is a rotor is there. So even a very small size equipment can give you a huge amount of product if it is a continuous pass, or even if it is a batch production size, even then as compared to mechanical string, the total quantity will be very, very high. So this technique is playing a very, very important role. So now I have discussed about the important point is that I have discussed about ultrasound, very good, efficiently, very efficient in laboratory purpose. And if you want to go for application purpose, and if you are confident that ultrasound results are very good, then I can, with full confidence, I can tell you that one should enter into the hydrodynamic cavitation as well as this rotor stator reactions, so that it can be scale up for industrial point of view, or even for small scale industries or for farmers and other applications. We can very easily use this one, and no any I can say sophistication is required for manufacturing of the plant itself. Now the last one, which is again typical gaining momentum. In the beginning of my lecture, I have told that mechanical string has a drawbacks, right? In terms of hours, it is there. But surprisingly, in last 1 year, even with mechanical string, people are doing some experiments by modifying the RPM. Most of the mechanical string, what happens, the RPM is around, say, 500 RPM, 1000 RPM, 1200 RPM, like that. This is considered to be small RPM. But there are devices are there, which is around, say, 10,000 RPM. So this is hand blender technology. ICA industry produces this hand blender technology, and we can have this blender at 10,000 RPM. At 10,000, more than 10,000 RPM, what happens? It has near the blades, the same cavitation techniques can be generated, because the fluid which comes in contact with the blade, the cavitation conditions are generated, and due to those cavitation conditions, bubble formation, growth, and collapse of the bubbles will take place. And due to that one, whatever we are achieving through ultrasound or hydrodynamic cavitation or rotor stator cavitations, we can generate those techniques. So, yeah, 250 ml sample size he has used, converted into continuous this continuous reactor. Even in static reactors, 250 ml size can be you can convert it into the yield within 5 minutes or 10 minutes. Only the point is that how to do the scalability of that one. So even this particular thing, in that case, one group in Thailand, they have used this hand blender. Another group, they have used this fruit blender, where almost again the RPM is 10,000, and they can convert into this just fruit blender. They can convert the reaction very fast. RPM is original, you can say the rated RPM was 20,000. Once you fill something, it will become it is slightly reduced RPM, and almost you can say you can get the 250 ml size reactants into products within 5 minutes. That is the typical beauty of RPM. It is there means, and again the authors are telling that due to very high RPM, the radical formation takes place, and radicals formation means the reaction is enhanced and catalyst requirement is lowered. And plus, there is no additional heat is required to submit those cases. Why? Because the RPM is very high. So heat generation engineer and the role of, since the shaft is there, so design people will come into the picture and they can try their luck into this kind of problem if they are able to generate 10,000 RPM or more than that. Because in that case, at the surface of the blade, you can generate the cavitation conditions. So this is also, we can call it as a process intensification technique and a modified high-speed reactors, we can call it as. And as per the industrial requirement, the flame requirement must be more than 95% in 15 minutes. So these techniques are following this one. So therefore, industrially point of view, they can follow. One thing is that you can have multiple rotors, or with big size rotors, if you can increase the size of the rotors for this industrial applications, in that case, your total size will increase. The reason why the cavitation conditions are generated, it is due to synergetic effect derived from the very high rotational speed of blender plates integrated with micro mixing levers from cavitation phenomena. And due to this cavitation phenomena at the blade, what happens? Heat and mass transfer is enhanced. The vigorously stirring, what happens? The temperature rise within 5 minutes, 60 degrees it can be raised, and due to that one, there is no external heating is required. So these simple devices can play a very important role, and even if properly designed, in that case, they can replace the hydrodynamic cavitation as well as rotor stator also, because they are well established in the industry. Only the point is that scalability is the issue. So almost I have covered ultrasound, this orifice type of hydrodynamic cavitation, rotor stator technology, and small scale but very high speed reactors. Almost you can say all these techniques can be applied for conventional bioenergy applications, right? So techniques, I have explained that one. Now I am coming to the applications. That application I have told you that the main this fuel are biodiesel, bioethanol, hydrogen, biogas, and battery. Of course, battery is not part of this bioenergy, but the point is that how the recycling of battery takes place. Again, these techniques can play an important role. 1 minute, excuse me, I'll just have one water and then I'll start. Now I'm coming to biofuels, and remember that as a faculty member, as a scientist, always you have to be taken care about the policies. If policies are favorable, then we have to switch over to the techniques, because ultimately the funds come through government and funding depends upon the policies. The policies point of view, you can say earlier ethanol was not, the food grains were not permitted to convert into the bioethanol. But now in 2018, the policy has changed, and damaged food grains like wheat, broken rice, and unfit for human consumption, whichever the grains are there, you can convert that one, right? So almost you can say surplus quantity of food grains can be converted into ethanol. That government has given the permission. And besides this one, due to this one, what will happen? This ethanol blended petrol, this petrol program was there. And in this program, what happens? Due to this food grains, which are not, can say, suitable for eating purpose, human consumption purpose, around 150 crore liter of ethanol was blended in petrol. And due to this one, what happens? We have saved a foreign currency of 5,070 crores. And also, there is a reduction in carbon emissions. And how much reduction is there? Roughly around say 30 lakh tons of CO2 emissions was reduced, right? So it is always a policy which matters. So from ethanol point of view, it is good one. Program is going on very well. Let us see what happened in the case of, you can say, the two important things is this bioethanol, which is substitute for petrol, and your biodiesel, which is substitute for diesel. Target point of view, our target is 20% blending of ethanol in petrol in 2030. And recently I heard that in the new policy, the target is preponed. Even in 2025, government has an idea that they want to achieve this 20% blending of ethanol. Biodiesel blending, normally you can say that due to failure of jet program, still almost you can say around say less than 1% or 0.12% of whole country, except in the Union Territory of Andaman and Nicobar and Lakshadweep, where OMC blends are around 10, because there the petrol is not available. In that case, they are using 10% ethanol in petrol. They are already using that. Now, another important policy is that we have to implement BS6. BS6 is a very stringent regulations, and already you can say in Delhi it has been applied, and all other countries, in the other part of the country, it is April 1st we have applied. So in that case, what happens? The role of renewable energy sources can play a very important role. In case of diesel, what happens? Around 850 crore liters of diesel is consumed every month in India. Now the government objective is that 5% blending if you require by 2030. In that case, the requirement of 500 crore liters of this biodiesel will be required. So at present, we are consuming 850. This consumption will increase in the future also, and therefore, can say we can use around say this is the diesel consumption, right? So based upon this one, we require 500 crore liters of biodiesel required.
So now the presentation is not visible. I think it exited.
Presentation is not visible.
Yeah, you have to reshare. Just in last slide, it disappeared.
Okay, then I'll just 1 minute. 1 minute. Reshare. Just do that entire screen and now it is visible.
No, sir. No. Now it is visible.
Okay. And now I'm just can say the PPT mode I'm doing now. Now it is okay.
Yes. Yes.
Yeah. Thank you very much, Bishwa. If there's any problem, please stop me so that it will be continuity can be maintained. Yeah. Thank you very much. Yeah. The point is that you see cooking oil quantity is so large that this can be a very good source, and this can be collected through hotels, restaurants, and government has a supply chain management is also there. So almost 110 crore liters of biodiesel can produce that one, and that can be a very important resource. And this plus a huge amount of castor oil is there, plus non-edible oils are there. And remember that nowadays, if you just have a proper mixing of the oils, in that case, properties of the fuel can also be improved. And that is the main area where people are working. Particularly the cold flow properties are important, and those properties can be improved. So this food security and supply agencies claim that India has the potential to recover 2.2 million tons of used cooking oil for the production of biodiesel by the end of 2020, and target can be achieved is properly this unused cooking oil or waste cooking oil. If you collect properly, then we have a target of that one. Waste cooking oil, because salt and other things are there, so some certain problems are there, but those problems are can be solved in the industry itself. The policy point of view, our policies are very clear that we have to go for substitute for biodiesel and up to 5% blending and 20% blending for the case of ethanol. With this target, the government of India is going on, and our research should also focus on this target. Rather than we can say that, okay, of course, experimental purpose, one can go that 50%, we can go for 30%, this biodiesel blending, etc. We can go. But we have to see that within 5% blending or 10% blending, how we can manage as per the policy, how we can achieve that. Now, you see, technology point of view, I have told. Now, what additional efforts we can do so that even these techniques can be further improved? In most of the cases, when biotechnology, what happens, whether it is a question of oil extraction from the seeds or main thing is that we have to extract the oil from the seeds. And the conventional technique we use it is through compression, right? The compression machines are there, and remember that compressor machine, using the compressor machines, or if you just abstract the oil from the seeds, your 50% price, or due to electricity consumption, what happens? They consume a lot of electricity because high pressure is required and very high electricity consumption is there. So due to that one, whenever you produce the biodiesel based upon the oil through this compression process, 30 to 40%, or even some of the cases 50% price is due to this compression process itself. So is there any way that, is it possible that can we directly get the oil from the seeds itself? And even those techniques can also be suitable for extraction of oil from in conventional, for example, say for edible oil also. Even in most of the cases, compression process is used from edible oils also. So huge amount of electricity is consumed, and the price of extracted oil is high because the operating cost is high. So for that one, this extraction process, which is called as in situ process, means through the oil we can extract directly from the seeds itself, or it is also called as a reactive extraction. In that case, what we do, we just grounded oil bearing seeds, means we just put it in the mixie or a typical grinder where we just broke the outer cell, and it will become a paste. A very small amount of electricity is consumed once we broke the seeds. I have shown here the castor seeds because we have worked in the case of castor seeds, right? And in that case, what happens when the seeds are broken, and these seeds we can directly add this alcohol, catalyst, and other things. So we can add, once the seeds are broken and become paste, and we can add this directly. In that case, directly we have produced the biodiesel. What is the advantage? Advantage is that instead of the two separate processes, now there is only one process, and therefore the time is reduced. Reduced cost associated with oil extraction also. So even this technique, not only for biodiesel, you can apply it for any oil extraction techniques, because in that case, the total overall price will reduce. And you know that nowadays the price of edible oil is very high. If you apply this technique, and plus you can ground it so that it will come in situ, and then you can apply hydrodynamic, you can apply rotor-stator, you can apply ultrasound, and due to this diffusion process, easily you can extract the oil. I'll just show you the apparatus in next slides. And therefore, the reduced overall solvent requirement is there. So this technique can play a very important role in electricity saving. So overall, you can say number of steps in conventional transfiguration of biodiesel. You see seeds are there, you have to crush it, then your hexane extraction is there, the transfiguration, downstream processes. Whereas in situ transfiguration, seeds, just crush the seeds, ground the seeds through this mixture, and then there is directly in situ transfiguration, and downstream side you can get the biodiesel. The number of steps are reduced in case of this in situ process, and this I am talking about biodiesel, but this can be applied for any type of seeds for extracting the oil. This is a very important step, and in that case you can save a lot of money or in terms of operating cost. Before I come to the apparatus, just try to understand the mechanism of solvent extraction mechanism, that how the oil can be extracted by the solvent from the seed itself. Just look at that. Outside it is, you can say the solvent is there. Solvents are of two types. One is that you can say non-polar solvents. Another is, you can call it as a polar solvents. Normally alcohols are the polar solvents, right? Now what happens? The solvents are capable of penetrating the cytoplasm. This particular portion is called as cytoplasm, right? Inside that one. This cytoplasm and this particular portion of the seed is there, and through this one we have to bring the lipid and the other portion through this one. Now, you see, polar solvent can also enter, and non-polar solvent can also enter, and the polar solvent can also enter, right? But the point is that this van der Waals forces are very weak in case of non-polar solvents, so they require a lot of time. Whereas if you use the polar solvents, what happens? There, due to the hydrogen bonding, what happens? They are very fast. So in the first step, what will happen? This polar solvent through this portion it will enter, right? So in the cytoplasm, and interacts with the neutral polar lipids, right? That is called as the step 2, to form an organic solvent lipid complex. And if it is a polar solvent, in that case hydrogen bonding will be found, and they will just collect this particular, you can say, the lipid protein combinations, and then it will come out through this portion like this. Continuously, you can say the polar solvent molecules will go, and this polar lipid linked to cell wall protein, this will, they will make a surrounding around this one, and then they will again come back outside. So this continuous process, if you use a polar solvent, this mechanism is a simple one and well established, and it will be very fast, right? So this is due to this reason what happens. Polar solvents, this is alcohols are preferred as compared to non-polar solvents. And as I have told you that polar solvents can break the liquid protein association by making a strong hydrogen bond with polar liquids, right? So due to that one, the extraction from the seeds will become very, very fast. The solvent liquid complex thus formed moves towards the cell membrane due to the concentration difference. Due to the concentration difference, the fourth step, what happens? It will come out. So starting one is the entry, catch hold of this lipid, travel, and then finally it will come out through this one. So this mechanism, how to enhance that mechanism, this is the mechanism, and through process intensification techniques, this enhancement will take place. So extraction mechanism remains unaltered for the conventional mechanical stirring process since it dominates by the interaction of solvent and lipid molecules. In case of ultrasound and your hydrodynamic cavitation or rotary techniques, continuous shock waves are formed, and due to diffusion difference, diffusion force, automatically the this lipid will come from inside to outside by means of solvent molecules. This mechanism play a very important role in extraction, and how to enhance this mechanism, again the process intensification technique play a very important role. Now, as I have told you that in situ advantage, right? It is advantage. Now, if in situ is clubbed with the hybrid reactor means, as I have told you that earlier, it is a combination of ultrasound and microwave. Ultrasound from the bottom we are supplying, ultrasound waves we are supplying from the bottom, and through this microwave we are supplying the two fields from this one. Just look at the microwave two fields, magnetic component and electrical component, both are perpendicular to each other, and these two fields will interact on the liquid, and one field ultrasound will interact. Three fields which are perpendicular to each other, which due to this one, what happens? A huge amount of turbulence is generated inside the microwave. And in case of microwave, what happens? There is a continuous dipole and non-dipole molecules are there. The molecules are structured in a particular direction. I will give you an example. When we cut the lemon, it requires a lot of efforts to get the juice, lemon juice, out of that particular cell, lemon cell. Now, if you just put a lemon for 10 seconds in the microwave and then cut it, with a single compression, we can get all the juice. Why? Because this whole structure of lemon is broken due to this microwave electrical field. This you can check at a household microwave. So this combination of in situ and hybrid, we have done it, and we have got a very good results that total cost can be reduced and using this microwave. Only the issue is that microwave plus ultrasound, this is a hybrid reactor, how to make it for scalable purpose. That challenge is remaining, and this is not a big one. Any industry, if they come out with some knowledge of ultrasound or microwave, they can go for a bigger size. The advantage in that case is that cost reduction may be about 50 to 70% you can reduce, and steps in biodiesel can be reduced, that simultaneous extraction and reaction can be possible. That is the main advantage of in situ. And of course, hybrid means ultrasound removes the mass transfer barrier and microwave removes the heat transfer barrier. So combination point of view, each technique can minimize its drawback and it can maximize its utility. Normally, as I have told you that there are certain difficulties are there, and due to that one, what happens? People are difficult that hybrid. So in that case, we can use them in our laboratory in CVBS and PDPU. We have developed a sequential reactors where this is a storage tank. Through this storage tank, through this storage tank, it will go to ultrasound. Then through ultrasound, it will go to microwave. Again, come back. So based upon this one, this is the circuit diagram we are having. So continue sequentially ultrasound and microwave. It will also enhance the reactions. So from that point of view, again, it is a very, very important one, and we have got a very good results. It can be scalability point of view. It's also good because microwave ultrasound are not hybrid. In that case, they are sequential. So almost we can say that in that case, 10 to 20 liters we can get it in 15 minutes we can get. So if you increase the capacity, you can convert into a continuous type of reactor also. You can continuously convert into batch type of reactors depending upon your requirement you can do. So this is the simplest reactor at laboratory level we have produced, and it is giving an excellent results. Even our recent papers it will be shown. Now, till date, almost 2018, 2019, scalability was an issue in case of ultrasound. Industry wants a big size. So what is the, I can say, in that case, how to convert the laboratory results into for industrial scalable point of view. So we know that developed worlds are very intelligent people, and they have developed, particularly you can say, these two companies are there, French company Hughes and Hilcher company Germany, and they are working for last 10 to 20 years in that area. So even small size reactors, they can be converted into 1,000 liters per hour capacity they can go. So here, all these are small, can say, from 40 liters per hour to 1,000 you can convert, and these are the different, very different multi-frequency, can say, components are there, and they are industrially it is using. But now the issue is that if you import it, the price will be high. So Indian industries, in combination with faculty and scientists, they should design indigenously this ultrasound so that scalability issue in our country can be resolved. The multi-frequency ultrasound they are using, even you can see that size is very, very large, 1,000 liters ultrasound. Inside that one, the horn is there, right? But in our country, size is not very high. The small scale ultrasounds very commonly used. But if industry demands and if industry takes this challenge, then obviously manufacturers will come with the higher size, big size of this ultrasound. And therefore, it can resolve the long pending issue that how the scalability is there. So that answer you can find out. So up to certain extent, this issue is resolved if you just go for indigenous way, the manufacturing of this ultrasound in a large capacity. Of course, at the laboratory level, we have produced, and you can go through this paper. I will not discuss about that one. It is open literature, it is available. Another, now quickly, I'll just see that, can say, I'm just giving you glimpses of those technologies, and these techniques can be very efficiently utilized for either pre-treatment process or directly conversion to that one. We can use that one. So one almost can say now, last 10 to 15 minutes, I'll just give the examples of those things. We know that can say, those who are working in the area of microalgae, dry algae process very energy intensive, because if you make it dry, huge amount of energy is required to remove the water and other things. So therefore, people are preferring this wet algae process. And in wet algae process, what happens if you pass through hydrodynamic cavitation, the cells, these are the intact cells, those cells will be broken away when it passes through this cavitation. And once the cells are broken, that reaction will become very fast. And this is almost, can say, this has been applied in our ICT, this Indian Chemical Technology Bombay, which is very, very popular in this development of this hydrodynamic cavitation. Professor Gogate and Professor Anirudh Pandit, who is the director of that institute, they are for the last 20 years, they are working in that area. And they have developed the expertise, and they are considered to be the leading zone in development of this cavitation techniques. So therefore, in a short way, I can say that hydrodynamic cavitation is a promising, novel, energy efficient methodology, and industry, almost we can use this hydrodynamic cavitation for industrial sector microwave cells, and this disrupt and further extraction of intermolecular compounds. So microalgae, if you use this as a pre-treatment process, certainly your results will be enhanced. Results will be very, very good. Again, in the beginning, the one rotor stat technology I have shown, in that case, a very small size you can go also. This is the open lid, right? If lid is covered from, I'll just convert to my rotor this 1 minute. Yeah, this lid, if you cover it, then very small size rotor stat technology, a small size sample, and this is a rotor. Cavities are there, blind cavities, and inside that one, the cavitation conditions are generated, and in a very fast way, small size samples can be converted to that. So this technique already I have explained, but with a pump, you can just connect that one, and Russians have used this technology that to convert very hot water, and so that ice from the, can say, due to ice fall, the ice surfaces can be removed from this one. In Western countries, they have different applications. In our countries, we can use this for different application purpose, and reactions can be utilized, right? So these techniques always, you can say, the point is that whenever the relative motion takes place, the forces exerts on the liquid in the space between the two plates. This one is the one will be the cover plate. This is the open one, right? The cover plate will look like this. So this reactor will an inner volume of, can say around say 200 ml, less than 200 ml, together with the detached rotor plate. You can say due to this one, what happens? The cavitation conditions are generated and reactions very fast. So this is a typical robust device. No rocket science is required, and quickly you can just apply that one. So this is almost, can say, for biodiesel purpose it is used, and for even petroleum technology, people have used for extraction of petroleum, the lubricant, etc. One can go for that one. In your food industry, people are using this one. Then your milk industry, dairy industry, people are using. So wide range of applications are there. Recently, almost you can say, even due to this cavitation generator, what happens? This microbacteria can be killed without addition of any chemicals. That is the advantage. So 75% bacteria if dies like this, and then 25% bacteria you can remove by chemicals. So less amount of chemicals you can use it. So this is the advantage, because in this microjets, they kill the bacteria also, and that is a very, very important one. Then another application is that you can say it is for bioethanol purpose. So in Italy, almost can say this Cavi beer is a patented technology, and they have used this venturi like this. The malts and other things, number of processes can be reduced. I will show you in the next slide, and directly you can get the alcohol for consumption purpose as well as for application purpose, because beer is an integral part of Europe and other things, and the quality they have to maintain that one. So using these techniques without compromising the technology, they can get a very good amount of alcohol in terms of beer as well as alcohol for different applications also. This is a typical process. I will not go in details, but traditional process almost has a huge number of steps are there: milling, preheating, meshing, and meshing out filtration, lautering. Then it is, you can say, heating. So these are energy intensive processes are there. If you just look at the hydrodynamic cavitation, then grains, almost you can say all these processes are combined into meshing, and quickly the number of steps are reduced, number of temperatures are reduced, time consumption is reduced, and then you can see that the same you can get the same product in that case with equal quality. So this is a typical reactor. It is there, developed in Italy. And if you just look at in conventional, what happens? This is, I'll just show you. In this slide, the main thing is that number of steps are reduced, temperature conditions are reduced, energy saving is there, and therefore hydrodynamic cavitation is a superior technique as compared to the traditional technique of this bioethanol production. And it has well proved, and even in 2016, there's one paper is produced, and even recently the new advancement has also come. So bioethanol also, by using hydrodynamic cavitation, you can produce it. This is the main outcome of this research. You can just look at here. This is, can say, in conventional techniques, after extraction, it looks like this. Whereas in the case of cavitation techniques, almost all the essence is purely, you can say, extracted from this portion in a very efficient way. So due to that reason, the yield quantity is very, very high. And these are the venturi method they have used, a patented venturi, almost kind of size and shapes they have developed. Italian group one has worked on that one. Then once you produce the alcohol for, I can say, for consumption purpose, then your foam stability and other things they have tested, and as per the standards, this foam test has been cleared by the alcohol produced from this one. The meaning is that bioethanol can be easily produced using these cavitation techniques. So in our country, what happens? We don't have to go for a big size plants. Even for small scale size plants, you can go for substitute for petrol, and for small size plants, you can go substitute for diesel substitute as a biodiesel. So agriculture purpose or small scale purpose, if you can have indigenously those things, it will serve a very important role. Even you can see that here. This is bagasse is there, and since bagasse cannot pass through the hydrodynamic cavitation holes and other things, so we can generate the cavitation conditions at the bottom pump. Through orifice it will pass, cavitation bubbles are formed, and those bubbles will directly attack on this bagasse and other things. And this is the hydrolysis process, where pre-treatment process is required for. Nowadays, what happens? Burning topic is that lignocellulosic biomass we can convert into, because this lignocellulosic biomass means it consists of lignin and this hemicellulose and cellulose. They are very bonded, very in a stringent way they are bonded. So point is that how to the disintegration, how to take the disintegration, and how you can take the glucose and other portion through hydrolysis method. So this technique is a very, very important role in this hydrodynamic technique. And you can see that, you see, cellulose percent and hemicellulose percent within pre-treatment time, 10 minutes or 20 minutes, you can get up to 90% yield here. What kind of shape and this venturi is there? So you can say different venturis people have tried, and they are told that, okay, 16-hole venturi plate is sufficient to achieve this target. So this is a very simple one. And if you give this treatment and this pre-treatment process for lignocellulosic biomass for production of alcohol, so it is a very, very easy way one can do it. It is not rocket science. Even other discipline, other than chemical disciplines, they can also enter into this in a very efficient way. Of course, I have already discussed about the shockwave power reactors. So this shockwave power reactors, wide range, other than petroleum, or you can say this biodiesel, bioethanol, non-fuel applications, people have come to this one, because the reason is that this is a very efficient way for producing emulsions and other things. Main thing is that some people call it as shockwave power reactor. In the beginning, I have called it as a rotor stator, because rotor is a moving part and stator is a stationary part. So this is a very, very important technique, which I have seen that wide range of applications we can insert in our country. And at present, whether it is a pharmaceutical industry, whether it is a dairy industry, whether it is a fuel industry, we are using the conventional techniques. Even in Middle East, Iran, and etc., they are doing a lot of research, and they are the excellent papers they are producing. Now, since ours is the agriculture country, the biogas production is a very important one. Here, this is a biogas plant is there, and in this biogas plant, what happens? If retrofittingly, if you just put this particular additional device, which is called as, this is the typical continuous ultrasound converter, where through this portion, you can just normally remember that biogas plant. We use the can say manure of cattle, and plus we can add the biomass. Combination is always preferred. The reason is that as an individual biomass, the quantity is not much. If you use pure cow dung or this manure of animal, it will can say it will give, but the results are not good. But if you have a combination of biomass plus cow dung, it will give you very good results. And if this substrate, if you just produce a substrate tank, and if it passes through this ultrasound, in that case, what happens? The biomass disintegration is very, very fast. That is called as biomethanization. And due to that one, what happens? You'll just see the results. There are three things. One, bottom results are this biogas production rate. Without these devices, almost you can say 15 to 17 this meter cube per day we are producing. If you use this ultrasound, and this is a homogenizer, almost like a rotor stator assembly, you will see that 15 to 20% quantity of biomass is produced relatively. Another important result is there. In this result, what happens? Not only the quantity I have already shown, but the quality is also improved by percentage increase of CH4. So here the point is that as compared to this conventional technique, if you just have a retrofitting of this one, the CH4 percentage, earlier it was hardly, you can say, it was 45 or something like that. Now the percentage is also increased. And due to that one, the main thing what we can conclude, percentage of biogas can be increased by this retrofitting device, as well as the quality of biomass quality of biogas can also be improved by increasing the percentage of methane. That is, experimentally people have proved it. So this is one application. The concept is that, you see, nowadays, if you just start an industry, you cannot say that I will use only the seed. You can get the seed, you can have a stem, you can have a leaf. All things are suitable. That one, suppose if you have a plant of 1 kg of castor plant, it will have this much fraction is seed, this much fraction is stem, this one is leaf. So our techniques must be there. Each and every component is important, and by processes are available nowadays, industrially viable processes are there, where we can get the product in terms of biodiesel, we can get product in terms of methane, we can get product in terms of ethanol. So all things can be, almost can say, fuel quantities can be earned. And in that case, if you have a combination of these techniques, the whole process will be profitable. And that concept is known as the biorefinery concept. And now the industries, conventional petroleum industries, they are entering into this one. And Reliance has already taken a decision that 35,000 lakh dollars they are investing on this biorefinery concept. And in that case, the main product will be biodiesel, biogas, ethanol as a fuel, and other products as a byproducts for different applications. Of course, hydrogen is not my area, but process-wise, it's a very, very simple one. We can use this electrolytic process. People are using, no problem, no issues. But if the same process is happening in the case of below the ultrasound, then ultrasound will have, due to radical formation, the electrolytic process will be enhanced, and you can get 10 to 20% additional hydrogen, and there is no problem. And if anybody gets 10 to 20% additional hydrogen, it's always welcome. So in hydrogen production, what happens? The use of ultrasound, such as sonohydrogen, chemical methods, these are considered to be greener alternative. Whereas sonochemistry is the heart of the solution. So sonochemistry enhances your process. It will not directly involve in the process, but it will enhance. Means your yield quantity will be increased with less time and less stringent conditions. So even this quantity hydrogen increase means it is directly help in the fuel cell, and fuel cell is the future technology. In this way, this ultrasound can help to enhance this technique. And another important point the government of India has planned is that they talk about the cash crops. Normally, we know that government of India says that we have to increase the farmers' income. Now, income just by growing the conventional crops, the income will not rise. That is a well-known fact. The point is that there are many types of cash crops are there where farmers grow it and sell it to a very small price to the middleman. So now, these techniques in a small areas, what happens? I'll just give an example. Potato price is very small, but the moment potato is converted to chips, the price rises 10 times, 20 times. And chip to produce these chips and other things, food products, it is not a rocket science. Even almost very small techniques, you can convert that one. So value addition is a very important one. And these small ultrasound devices, by using the cash crop seeds, you can convert into very, very important nutrients, which has wide range of applications in medicinal purpose or eating purpose or other things are there. So these techniques, what happens is ultrasound can play a very important role. And if these techniques are inserted with the agriculture, in that case, what will happen? The farmer's income will tremendously grow and he can achieve that one. So here again, you can see that ultrasound means this is a matrix, and through this matrix, the implosion of the ultrasound will take place here, and this outer cell will break, and these nutrients can be collected that one. So in pharmaceutical industry, in this medicinal purpose, horticulture, a wide varieties of applications are there, where at present what happens, seeds are there, you have to boil the things, and then boiling the things, vapor formation, condensation will take place, they are energy intensive. Here, without any boiling, due to this ultrasound and diffusion process, quickly you can abstract, and they are very efficient when one can do. So industry point of view, you see this sonosoxylate is there, where almost solid liquid particles are there, and through this one you have to do the boiling process. Pure soxylate means through boiling, condensation, it will go. But if you have a combination of this ultrasound portion, in that case, half of almost you can say here it is 6 hours. Here it is in 30 minutes you can do the process. So that is the typical advantage of this is called as the second method you can call it as sono ultrasound method, where partly it will be boiling, but this due to this one what happens, the extraction is very fast, and people have developed in France, and people have developed, and even this soxylate is a very simple device. If you have to insert this portion with the soxylate and combination, if you do it, then extraction of the oil will become very, very fast. So this is called as both soxylate extraction and ultrasound extraction. Combination will reduce the extraction time and by enhancing the mass transfer rate. So this is almost, you can say, a proper conventional technique with modification with this sono ultrasound, we can get excellent results. This is almost, you can say, this is for microwave, big size microwaves. Now they are available. So even from microwaves, very phenolic compounds are there. So those phenolic compounds easily you can disintegrate into these devices. And the main reason is that this dipole moments takes place. Unorganized molecules can be organized way in the case of due to field of microwaves, which is not possible in conventional heating. So due to this thing, microwave can play a very important role in phenolic compounds, and even sample size up to 75 kg can be treated in the recently developed microwaves. Scale up, you can see that here the small size, you can scale up to a very big size. I'll not go in a very minute details. The main thing is that extraction part of view, bioactive compounds you can produce, and as I have told you that phenolic compounds, phenolic acid, this flavonols, anthocyanins, antioxidants present in the these fuels, polysaccharides, and uh, thousands and thousands of examples are there. Now remember that pharmaceutical people, agriculture people, or different people, they do not know the technology. Technology people do not know the applications. There must be a proper understanding between the two. Gaps should be reduced, and one should not shy away that developing the technology and how this technology can be developed. So these techniques which I have told, ultrasound, this ultrasound with microwave, and this hydrodynamic cavitation, and this rotational technology, these techniques, has you name it and I will tell you that in that field it's applied. So, and these are all recent developments. It has not it has not inserted into the industry, but it has people are expert are saying that these techniques can play a very important role to reduce the total size and to reduce the electricity consumption and various other aspects. So this extraction, etc., pharmaceutical applications I have given. Then oil crops I have already discussed that can say they can be used soap, perfumes, food, flavoring, medicine use, and the combination of ultrasound, can say extraction and shock select can demonstrate it. I have given the application where in 30 minutes you can get the results, whereas in individual shock select it is 6 hours if you have to use it. Oil crops, it is the best remedy for that one. Then lipids for fuel purpose, as you were told that lipid extraction, very easily you can do it. And this microorganism, again, can be utilized. Hydrodynamic cavitation demonstrates very high lipid extraction efficiency from dry nanochlorophyll. That is the typical microalgae it is there, which is vital for biodiesel production. So I am giving a couple of examples, but the conceptually it is like this. Our fundamentals are clear, and if the reaction fundamental is clear, then the same reaction, if you use this process intensification technique, then you can have an industrial plant or industrial point of view, the suitability will be there. So in toto, I am not going into the micro level, but the point is that it has a wide range of applications suitable for industry, right? So this is the one slide it has produced in 2020 paper, and they have called it as this technique as a technological breakthrough and fruits, vegetables, and various places, because this technique has a 50% saving in core corresponding time and energy consumption, 25% cost saving, reduction and better reuse of waste stream. Even in developed world, people are talking about the boost to the farmer incomes. Output, can say this, various examples are there, economic benefits are there, agriculture it can be used, and due to the efficiency of the techniques, what happens, this greenhouse gases are reduced, food technology it can be applied. So wide ranges are there, and due to that one, people consider it a very, very, you can say, this innovative technique as well as a breakthrough in the industry. That is in total, in brief, I want to say that one, this slide. And there is one more last slide almost, we can say that even this recycling, the ultrasound, what happens, the waste lithium and this lithium ion batteries powder is there. So you can say bleaching, etc. You have to high temperature boiling, etc. You can do in conventional techniques, right? Because remember that we are importing this lithium bromide batteries. Once it is spent, what to do with that one? No idea. Nobody is having the idea. If you throw it away, it is environmental. It is not environmental friendly. So properly recycling is a very important one. And in that case, one Chinese group, they are working in that area because China is exporting. So almost we can say this recycling process can play an important role. And through this ultrasound, the very good recycling is possible. And they have demonstrated this one. And once this is possible, they have not worked in the area of hydrodynamic cavitation still. So this recycling, if it is possible through ultrasound, it will have to be automatically possible through hydrodynamic cavitation as well as the rotor-assisted technology. Because this is a big problem. We are already importing a huge amount of this battery. And once this battery application, battery utilization is over, then the next part is that just like you cannot throw it away, just like e-waste or something like that. You have to recycle that one. In that case, these techniques can play a very important role. Right. So these are the different steps through which you can say discharging, dismantling of this lithium-ion batteries one can do, and this is very recent techniques. Can say people are trying to apply, and it is still at a developing stage. But India have to think about that one, that how to recycle the batteries. That's very important, right? So now with this one, I'm just coming to that point. last 2 to 3 years, in fact, we have started with Dr. Paul in 2010-11 with the hydrodynamic cavitation, and we have successfully developed a plant. And at that time, we are just only focused on biodiesel only. But later on, we have discovered that this technique can be have almost all walks of the life, from water to industrial water waste or dieselers and pharmaceutical industries, oil extraction, fuel, petroleum industries, because the point is that this enhances the process. And due to that one, now almost all walks of the industrial life, this has been going to insert it. Every day the new paper is coming, every day the new ideas are coming, and these techniques you can apply it in a very fast way. So technological, and now the main issue in that case is that, you see, these are the problems, we can call it as hybrid problems, or interdisciplinary research is required. In that case, individual person, 2 mechanical people, they are called 1 + 1, 2, you can call it as. But 1 mechanical plus 1 chemical, they will be equivalent of 11. The point is that nowadays, almost can say that everywhere in every institution, we have hypothetical boundary lines of departments, mechanical, chemical, something like that. For administrative purpose, it's okay. But from industry point of view, from research point of view, this is a drawback. So these boundary lines we have to come out, and teams should be prepared in such a way that 1 mechanical, civil, electrical, or combination of teams must be there. And then you can easily, quickly solve an industry problem, because industry problem is, it will not classify it as a mechanical, civil, electrical. Problem is a problem, which will have partly mechanical, partly electrical, partly chemical. So in total, you can have to give the solution. If you give a solution to industry that, okay, 30% I can solve, no industry people will come to you. They will say that this is my problem, are you able to solve it? As an individual, it is difficult, but different men from different branches. For example, I am working here, I am a mechanical guy. My friend, Kodgire, who is a chemical guy. So we two are complementary to each other, and based upon that one, we have successfully produced couple of patents, couple of very good impact factor research papers. So this is only possible because we are from 2 different disciplines. So this is the main requirement in that kind of technologies, and this is normally, can say, we grow conventional techniques that, okay, this is my area, this is my area, and we individually works. But all these areas which I have discussed, in that case, a combination of teamwork with different branches can certainly give you a very good results. So these techniques are the future techniques, and ultrasound, of course, well established. But even nowadays, the recycling has been solved. Recycling, scale-up techniques has been solved. Hydrodynamic cavitation successfully applied for scale-up processes. Rotor-stator technology now coming very fast and can be applied in all walks of the life in industry. And these techniques now really have future. But unfortunate part is that these techniques, I have seen that even in our education, etc., faculties are not aware of that one. Plus, this has not been introduced to our students also. So it is our responsibility that see that new knowledge is coming, and new knowledge how we can transfer to our students by means of research as well as education also. And at the same time, in research point of view, we have to work together with different streams of the people. In that case, I can assure you that success is guaranteed, right? With these are the main concluding parts, and recent literatures I have collected. And these are the couple of developments we have taken place in our laboratories. Ultrasound, we have developed these reactors, and a couple of papers we are producing, some photographs are there. So these are the small development of contribution. Almost can say in our laboratories we have 5 patents and 7-8 reactors we have developed. And with this one, I would just like to end that one. And this dialogue of this, I'll just do that. Look deep into the nature, then you will understand everything better. And that is the main knowledge, that we have to go deeper, and sometimes the invisible things, if it is not available, if it is not invisible, then we have to see that we can understand the nature very well. And if you understand the nature very well, we can say outcome will be very, very obvious. So with this one, again, a lot of thanks to all the organizers, and wish you that I hope that this particular STP will be a great success, and this will be almost, can say, very, very important one. So with this one, I am just ending that one, my lecture, and I'm very, can say, any question answers are there, I will be glad to answer for that. Thank you, Dr. Paul. Yeah.
From the participant, if you want to ask question from Professor Kachhwaha, then please ask one by one. Mr. Manoj, Dr. Manoj.
Okay, sir. Okay, sir. I will ask after.
Okay, Dr. Manoj Shah, if you want to ask question, please ask your question. I think you are raising hand from long time. Okay, anyone other?
Sir, myself, Dr. Mayank Pandey. I want to know one thing. That is the future is of electrical vehicle. So disposal of this lithium-ion battery and all other things. R&D are going on in respect of way how to dispose them safely or not. This is my question.
Yeah, process is there, right? But in those process, what happens? We are for recycling process, there are secondary pollutants are produced, and plus recycling process requires high temperature and pressure conditions. All these techniques are old techniques. Now our process should be in such a way that while reprocessing, the environment must not be affected, and there must not be secondary pollutants generated. So this ultrasound process, what happens? We are reducing or minimizing the secondary pollutants, as well as temperature and pressure conditions are reduced. So this process will be very, very helpful. And in our country like this, where almost we can say we are not having lithium, we are importing it. So the moment battery comes, then the point is that recycling development is a very, very important aspect. I hope I have given an answer for that.
Okay, thank you, sir. Thank you, sir. Thank you.
Okay, anyone else?
Hello.
Yes, Jan sir,
I just want to say good morning to Professor Kachhwaha ji. I am Pradeep Jain from DTU.
Welcome, Jain sir. Welcome. How are you, sir?
Fine. So you have given the very nice presentation, really wonderful presentation, and whatever going on, new techniques for the development of this production of biodiesel. And I have also experience in my MTech project about 20 years back. I did my MTech project for this biodiesel where I use this castor oil.
Yes.
And here you are talking about regarding this castor oil.
Yes.
My question, not question, just query. This in case of biodiesel, you are saying this used cooking oil potential is very high, and you are saying about 220 crore liter potential is there in 2022. So I just want to know, is any data is available? How much we are using today? This type of data is available. Because in biodiesel also we have so many times we are saying this is the potential, but we are not able to do due to various reasons. For cooking oil, I think this has the very good potential, and you have also given the data. How much we are using? Is any type of data is available for this right now here?
Yeah, I will tell you that. You see, earlier it was a policy point of view or lacking, but nowadays you see government has a typical can say this what is that called the website. It is available. Suppose I am having 1 liter of this waste cooking oil, I can go to this particular web, and then I can say that okay, I am having this one. As per the government norms, the vehicle will come, it will collect the biodiesel, and it will pay 30 rupees for waste cooking oil. So this is the rate decided by the government. So but still there is a lot of work to be done. The supply chain management, there must be a proper can say supply chain management must be there. And almost in I remember that in Delhi it was 5-star hotels, they have to collect it and they have to give it to railway where they have a plant. So other hotels and etc., what happens, people are continuously using 2 times frying, 3 times frying, which is not good for health. So proper collection from all these McDonald's and restaurants and other things, the collection mechanism must be there. And now in Gujarat, people are developing, because ultimately you can say this is a resource. So already the government is encouraging and how to collect those resources. And then at one point they collect all the things, and then they want to sell it to the industry. So this supply chain management is still at a developing stage. And the prediction is that since we all know that we always go to hotels, restaurants, other things. The restaurants are using this one, and good restaurant means they should not use it after 1 or 2 frying, because this is a norm. And if they use it, this is they are going against the norms, and that will not be helpful for the health purpose also. So always in our this food industries, our growth is continuously going on, and based upon that one, this FSSI, which regulates the food products and norms and other things, so they are producing this data that this is the edible oils directly we cannot convert, But the moment edible oil is used for first frying or second frying, then this becomes a non-edible oil. And that non-edible oil is a source and which is the highest in our country because population is high and consumption is high. So from that point of view, this is considered to be a very good resource. In combination of with castor oil as well as other non-edible oils, we can use the combination. And I have observed that in combination, if a proper combination, if you use it, then your properties of biodiesel is also improved, which is important from vehicle point of view. I hope, Professor Jain, I have given the answer.
Okay. Thank you, sir. Thank you.
Thank you.
Okay. Any other from the participants who want to ask question?
From Harijan Das sir, can the oil and grease from hotels and restaurants collected from the wastewater screen pit can be converted into bioethanol? Many times we see that greasy waste contents chalked in the drains, etc. And if it is separated, can it be converted for bioethanol production?
You see, normally, because bioethanol, actually, I have not worked in that area. But the point is that, you see, the reaction, what is the reaction? Normally, because hydrolysis or anything, we can just add some, can say, this NOS solutions, etc. We can add that one. So that reaction, reaction-wise, there is no issue because fundamentals are very clear that that can be converted, right? But if you go in a conventional way, then conversion will be very slow. It will require a lot of time. So people are not going for that one. But if the same conversion, grease and etc., if you collect that waste water and other things, and if you apply this technique, right, based upon the fundamentals, which are the knowledge already we are having. So if you apply using these techniques, then the point is that conversion will be very, very fast. Time consumption will be less. Your this what catalyst requirement or any other thing, it is solvent requirement, etc., that will be reduced. So that point of view, these techniques can enhance the techniques, and due to that reason, what happens, people are inserting those techniques into the production of bioethanol. So what you are told, by applying those techniques, certainly it will be possible. I hope I have given the answer, or any other query. Any other, if I have missed the point, Dr. Paul.
I think after properly removing the water, that can be used for biodiesel production as well.
Yes, why not? Because you see, suppression, point is that the suppression process, again, the suppression process, if you use boiling and other things, then it is energy intensive. But suppression, etc., if you do by using those techniques, in that case, what happens? The reaction will be very fast. That is the main point. So wastewater treatment and other things, even in biodiesel production, you see KOH, if you add it, then it's a waste. Then how to remove the KOH and other things, even this cavitation technique can be useful for wastewater treatment also. That this has in the literature it has come.
Sir, Sheel Mehta is also asking a question. Sir, is there any RPM range for the rotor stator technique to the biodiesel production?
Yeah, that is a little challenging, right? Not challenging. You can say that for each and everything, for your experiment, you have to perform. If you remember that, I will advise that nowadays experimentation is become a very, very scientific way. Suppose I have 3 variables in which RPM is also one variable. Then if I know that RPM, normally you can say 3000 RPM, it may fluctuate between 2000 to 4000. So in that case, my levels are 2000, 3000, 4000. So in between that, can say nowadays, many experimental techniques are there. For example, say 3 variables, 3 levels. So how many number of experiments I can do? For that one, I can apply box beacon method and this central difference methods or Taguchi method. So based upon that one, I can find out the optimum values. But only issue is that lower range and upper range, I should know it. So this is through past experience of those who have done the experiments, and plus through zeroth experiments, we can find out. So point is that normally you can say 3000, sometimes 3000 plus literature it is available. In some of the cases, it is 2500 to 3000 is available. So at this RPM, which is very easy to generate, and at this RPM, this cavitation conditions can be easily generated, and the proofs are available. So RPM, can say this RPM point of view, the information is available in the literature, and that RPM generation is also not an issue because electrical motors are there. They can easily revolve this rotor stator shaft, rotor shaft at around say 3000 RPM.
Okay, sir. One other question will be asked by Nazim Khan. Nazim sir is student of the PhD in the DTU.
Okay.
So he asking how practically possible to produce the biodiesel in a large scale with a micro channel.
Micro channel, the point is that very efficient technique, and you can get that one right. Now the micro channels, etc. People are working in that area. Literature is coming. You see, micro channel point of view, the reaction is very fast, but channel size is very small. So you have to you are just like heat exchanger. You have to expand that device, right? Up to what extent you can do, up to a certain extent you can extend that one. Then after you have to use the multiple times, right? So micro channels, people are working in that area, and for medium scale, it's good. But for you see industry, etc. For normally what happens in Europe and USA, what happens, they go for million tons of liters, something like that. So in that case, they use this very vertical structures called as what is that called? This evaporation and condensation phenomena takes place. So those are reactors. They call it as big size reactors. Vertical industry reactors are there. So micro channels, they have to go a long way, and of course, small size per unit production point of view, they are good. But for very big sizes, again, a lot of can say I cannot exactly say that up to what big size you can go. But for normally what happens, you see, there are medium scale industries, etc. It is there. From that point of view, medium scale, etc. These devices are very good as compared to go for mechanization or large production and other things. In that case, what will happen? Employment will reduce. Big industries will come into the picture, and they will govern the things. So rather than that approach, I prefer that small scale is the more important, and for small scale purpose, certainly you can say that this micro channels can be utilized. But answer, you can say exact answer is difficult at this point to predict.
Okay, sir, what is the impact of mixing of ethanol in the SI engine fuel in terms of the cost and efficiency?
Now the point is that, see, I have ethanol point of view. Main thing is that whenever you mix the things, certain standards are there. Standards should not deviate. So diesel standards, it is there. Suppose if you add the ethanol, then it will have impact on the this what is that called? This ignition point change will take place because due to these properties. I have not added the ethanol, but of course 5% ethanol one can add it, so that the point is that ignition properties can be improved. But one important point is that pollution is the main aspect. So from that point of view, what happens? I have added this N-butanol, this and biodiesel plus diesel plus N-butanol. In that case, what happens? The main drawback was that with biodiesel, NOx formation enhances. All other pollutants reduces, but NOx formation enhances. So without changing the can say dynamics of engine, how we can reduce this this NOx formation? In that case, we have found that 5 to 10% bioethanol, what is that? Butanol and butanol. If you add it, then without all pollutants will reduce, performance will not reduce, but your NOx formation can be reduced. But you have asked the question regarding this petrol. So I think you asked the petrol or diesel addition of ethanol.
Petrol.
The petrol, to almost you can say people are in Brazil, etc. They are utilizing that 50% bioethanol they are mixing, and they are running the vehicles very well. So bioethanol, this bioethanol is a pure substitute for petroleum itself. So there are no issues.
Up to 85, sorry, up to 85% also they are mixing with little modification in the engine to retain the same power.
Sir, so what is the impact on efficiency of the engine if we mix the bio fuel in the engine?
Because of its oxygen content, but the only if you don't make changes in the fuel supply system because of the low calorific value, because ethanol calorific value is almost 2/3 of gasoline. So your power gets reduced. So you have to make some changes into the fuel supply so that you can get the same power. That's why pure ethanol or E85 vehicle are different than the gasoline vehicle, in which you can go for 20-30% blend. If you go for more, then you have to make the modifications.
Okay, any other from the participant?
Today afternoon we'll be having a session of Professor Maji. So he is expert in that alcohol fuels. Yeah. More we can discuss with them. Anyone else? Any other question? And so just we discussed about microchannel biodiesel. This can also be tried with the ultrasound. ultrasonic cavitation, then it will be much better. It's lower efficiency can be.
Yes. Yes. Point is that you see, techniques wise, individual techniques with combinations, various permutation combination is possible. In combination, it is assured that can say the combination output will be much better as compared to the individual techniques. This is a well-established fact.
Thank you, sir. We are using just these techniques for the biodiesel production, but you have given an insight how it can be used for various other purposes also, in industry and in research work.
That is important, because sometimes you see we have started work in 2010-11. At that time we have only focused on biodiesel, but we are not focusing on the other areas. So you see, when we work in an area, then we have to be and have a typical target that in what way the same technique can be applied in other fields. So this technique has hundreds of applications with same apparatus. So from that point of view, it is very important and we can contribute for society. That is my point.
This information is very useful for a number of young participants who are planning to pursue their PhD research work. So this is very, very much informative and important. Yes.
Okay, if no one want to ask question, so I thanks Professor S.S. Kachhwaha for the wonderful presentation and for share his knowledge with the participants. So I thanks again Professor Kachhwaha, and then just end this session here. We will meet again at 12 o'clock for the new session.
Yeah.
Okay, thank you, sir.
Thank you, Dr. Junaid. Thank you very much. It's a really great feeling. And thank you, Dr. Paul. And may I leave now?
Thank you, sir. Thank you very much for your time.
Yeah.
Okay, thanks to all. Thanks to all participants.
Thank you, sir. Thank you.
First email, or you can take it from me also. Those who want to pursue any other having questions or pursue the research work, you may contact. So thank you, Junaid sir, and other participants.
Thank you.
We will be meeting
Okay,
at.
thanks, sir. Thanks, sir. Thanks, Kachhwaha sir, Mitpal sir, and each and every participant.
Again at 11:55, so that we start smoothly at 12. In next session, there will be 2 speakers, so please join on time.
Okay.